Dungeness crab fishery is really important for the state of California. It makes up over 26% of the revenue associated with commercial fisheries for the state. So in 2014, we had this large marine heat wave. And during that event, we had the largest harmful algal bloom ever recorded in California coastal waters. The harmful algal blooms create a toxin which gets into Dungeness crabs. The crabs just go on acting the way that they do, but it does affect mammals and birds, so can actually cause detrimental human health effects. It's pretty clear that warmer waters trigger these harmful algal blooms. In response, managers will delay the Dungeness crab fishery, or they'll close the fishery to protect people from the toxin, which then can impact the fishery and people's livelihoods. If fishermen knew where harmful algal blooms were going to occur, then they can adapt where they're actually fishing.
My objective as a postdoc on this project is to understand how crabs accumulate and then what's called depurate domoic acid under different temperature and oxygen conditions. We have 16 different tanks, all of which exist at one of 3 temperature levels or 2 oxygen levels. Once we've completed the dissections, we can run and analyze the samples for concentration of domoic acid and actually be able to say something useful with all those tissue samples that we've collected from the lab. I think what's so neat about this particular project is we'll be able to provide that information to stakeholders and also feed that information into future cast models that can help us better prepare and better plan.
We have a team that's creating a model across the state of California that's going to show where harmful algal blooms are occurring or likely to occur in the future, where we think the Dungeness crab populations are going to be most abundant, and then where we think the domoic acid loadings in those crabs are going to be the most potent. Then we have a social science team that's talking to fishermen and managers about what their needs are and how to actually refine the research for their needs.
We work with the researchers on the team to help translate the science to the fishing communities, and then also to just make sure that the research is applicable to their real-world experience as opposed to just being an academic research project.
It is absolutely critical, actually, that lab-based, modeling-based efforts obviously be based on the best available science and be ground truthed and informed by local knowledge and experience.
So we're really hoping that this project is going to improve the livelihoods of the fishermen who rely on Dungeness crab, as well as the relationships between managers and fishermen as they try to work together to keep the fishery open in the future. As climate change has progressed, many of us are stepping into that solution space that says, okay, so this is happening. We all know it's happening. We're seeing it and experiencing it firsthand. So how can we use this toolkit that we have as scientists to actually help society prepare?